P bar equal to I plus 2j minus 3t plus lambda into bracket 3i plus 2j plus 6t and q bar equal to in bracket 5i minus 2j plus 7 plus mu into bracket I plus 2j plus 2k is given options cos inverse 17 by 20 B cos inverse 20 by 20 option C cos inverse 18 by 21 option D cos inverse 19 by 20. Here equations of two lines, they are given in vector form and we have to find angle between lines. Observe the options. Each option is in terms of cos inverse. It means that it is not standard angle. Equation of line. Vector in first bracket, position vector of point on the line. Vector in second bracket, multiple of lambda. It is vector parallel to first line. This is position vector of point on second line. This is a vector parallel to line. Now as we have to find angle between lines, here it is sufficient to find vectors parallel to line. Vector parallel to first line we shall denote by B1 bar. 3i plus 2j plus 6k. Vector parallel to second line we shall denote it by B2 bar. I plus 2j plus 2. Now here vectors parallel to lines are known to us. It is convenient if we find direction ratios of these vectors. In vector, coefficients of unit vectors ijk, they are nothing but direction ratios of vector. So for B1 bar, direction ratios are 3 to 6. For vector B2 bar, direction ratios are 1 to 2. Now direction ratios of parallel lines are same. Direction ratios of vector B1 bar, they are nothing but direction ratios for first line. Direction ratios for vector B2 bar, they are direction ratios for second line. So we know direction ratios of two lines. We can find acute angle or angle between two lines. A1 3, B1 2, C1 6. For second line, direction ratios we shall denote A2 1, B2 2, C2 2. Cos theta equal to a1 a2 plus b1 b2 plus c1 c2. In numerator, sum of product of direction ratios of two lines. 3 into 1 plus 2 into 2 plus 6 into 2 divided by under root sum of squares of direction ratios for first line. Under root 3 square 9, 2 square 4, 6 square 36. Under root a2 square plus b2 square plus c2 square. 1 square plus 2 square plus 2 square. 1 square 1, 2 square 4. 3 plus 4 7 plus 12 19 divided by 36 plus 4 40 plus 9 49. 49 perfect square root 7. 9 perfect square root 3. 19 by 21. It is value of cos theta. It means that theta is cos inverse 19 by 21. And here answer is option D. Next example. The vector form of equation of line. Your equation of line, it is given in Cartesian form. X minus 2 upon 5 is equal to y minus 1 upon minus 2 is equal to z plus 4 upon 3. Equation of line is given in Cartesian form. Same equation we have to convert into vector form. Option A. P bar equal to 5i minus 2j plus 3 plus lambda into bracket 2i plus j minus 4. Option B. P bar equal to 2i plus j minus 4 plus lambda into bracket 5i minus 2j plus 3. Option C. P bar equal to minus 2i minus j plus 4k plus lambda into bracket 5i minus 2j plus 3. Option D. P bar equal to in bracket 2i plus j minus 4k plus lambda into bracket minus 5i plus 2j minus 3k. Equation of line, it is given in Cartesian form. So this equation, it is of the form x minus x1 upon A is equal to y minus y1 upon B is equal to z minus z1 upon C. So from equation of line in Cartesian form, we get coordinates of one point on the line and direction ratios of line. So coordinates of point we shall denote by x1, y1, z1. So x1 2, y1 1, z1 minus 4. From numerator we get coordinates of point on the line. Denominator gives us direction ratios of line. A 5, B minus, C 3. Observe options. No option contains Cartesian form. Every option contains vector form. It means that we have to convert equation of line from Cartesian form into vector form. For getting equation of line in vector form, we should know position vector of one point on the line. Suppose this is point A, whose coordinates are 2, 1, minus 4. Its position vector we shall denote by small letter A bar. Coordinates of point, they become coefficients of unit vectors I, j, k. 2i plus j minus 4. To get equation of line in vector form, we have got position vector of one point on the line, but still we want vector parallel to line. To get vector parallel to line, we know direction ratios of line. From direction ratios of line, we can write vector parallel to line. For parallel lines, direction ratios are same. Suppose B bar is a vector which is parallel to line. Then direction ratios of line, they become coefficients of unit vectors I, j, k. B bar 5i minus 2j plus 3. Equation of line passing through point A with position vector A bar and parallel to vector B bar is R bar equal to A bar plus lambda B bar. Put the corresponding values here. A bar 2i plus j minus 4 plus lambda into bracket B bar in bracket 5i minus 2j plus 3. Compare it with the options. We can observe that here answer is option